All right. Welcome to AI Adventures, Adventures with Yufeng, live show where we explore new and interesting kind of concepts, tools, and ideas, typically live. And my name is Yufeng Guo. I'm excited this week. We're going to be working on hyperparameter tuning today. And yeah, it's just me today. And thank you for those of you joining me live, as well as those of you watching the broadcast later on YouTube. This show, we've been doing this for a couple episodes now. We started out with a few interviews. Early on, it was the first one we did was with Brian Dorsey on virtual machines, and that was a lot of fun. Learned a lot about virtual machines and kind of just the fact that they're not really just like units of compute. They're really spread out, and when you think of it at the data center scale, it's really quite something. And then we met with Brett McGowan, and we talked about serverless, a different angle to think about kind of this compute spectrum. I really got a much better understanding about serverless, and we got to play around with a little Cloud Functions and Cloud Firestore, which was a lot of fun. And then we went on to the show. We wandered off to AI explainability, kind of a left turn there to chat with Sarah Robinson. We just barely got the notebook working in kind of that 1 hour time slot, and in Colab. That was a lot of fun. So if you haven't seen that, definitely catch that. Last Friday, I played around with training custom models in containers on AI platform training. And so I thought it would be interesting this week. One of my colleagues pinged me some new samples they had recently put up around hyperparameter tuning using the kind of new hypertune libraries, and that they had just published it. So I'm going to pull that up, and today we're going to play around with that, see where this journey takes us. So let's switch over to the desktop. There we are. And and I should remind folks that we are live, so be sure to hit up the chat down below or off to the side, depending on your window layout, and ask questions, say hello, and we can kind of interact that way. So today I don't have necessarily like a code lab or something to go through, and it's something that I've been thinking about potentially doing, where I'll like run through a quick start or code lab and try to connect the dots kind of between the lines, right? Reading between the lines of the instructions, because a lot of times the instructions, as complete as they like to be, are missing just little things. And I think it might be fun to, figure it out and connect the dots that way. So with that said, today we got Hypertune as our library of choice. Let me scale this window a little bit for us here and try to fill out the screen a bit. Oh, and Google Cloud AI Developer Relations AI Training says, "Hi from Bill. Great to see you. And see you're switching accounts a little there to get yourself lined up there. But yeah, thank you for tuning in. Great to have you on. And so today we'll look at this Hypertune library, right? And looking at this, I haven't just, in the interest of full disclosure, I did not write this library. I honestly haven't looked at it that much. So this is, if you haven't seen this much either, we're on the same page here. So, excited to kind of dive in and try to understand this together. So I think what we can do is, it looks like they want us to get this set up first. So we'll look at the main concepts shortly. Let's get this repository cloned in and get our workspace set up. Last time we used, what did we use last time? I think we used AI notebooks in the end. And so today we'll probably end up using the same thing. Having that compute offloaded was really nice. Really appreciated not having to, bog down my CPU while running the training on my local machine. So I think I'd like to do that again this week. So I believe this was the machine we had. There's this is zoomed in a lot. I'm going to go over to AI platform, choose notebooks, and one of these. I think this is the more recent one. Yeah, the 2020 machine. I've got a P100 hooked up to it. We're going to be training with this. It looks like this repository is going to play around with ResNet. So at least a P100 I think will be handy. So I'm going to start this machine and let that process kick off. What's nice about AI notebooks is that it's not just a virtual machine in the back end. There's also the piece in between that connects the machine with JupyterLab. And that reminds me, they just launched Python 3.7 support on these. So let me take a look at which version of TensorFlow it wants to use and spin up a new machine and see if we can't get 3.7 instead of 3.5 on here. Let's see here. Today, can we get a view on what library it's going to use? It's unclear which version of TensorFlow they've implemented. This sample is adapted from the official samples for tuning ResNet 50. What do we got over here? So this is from CloudML samples versus Google Cloud Platform / AI Platform samples. So subtle difference there. This one doesn't talk much about what version of TensorFlow to use either. So I'm going to jot that down on the side here just as a question to perhaps bring to the team. And one of the nice things would be to have these questions brought to the team that I can kind of like try to use this as a feedback mechanism. So again, for those of you with questions and confusion points, I can happy to log these down and bring them to their attention. So what TF version does this sample use? It'd be a good thing to get that set up correctly. I suspect that if they have like a, oh, they got a build, they got a YAML, and maybe they have a requirements. Maybe in their init. No, it's a blank init. Perhaps their Docker file would show it. Ah, there we go. So they're using a GPU-enabled version of TensorFlow 1.15. So that's what we'll find. We'll go to TensorFlow 1.15. We're going to play it with GPUs, but not that GPU. So I'll just select it for now. And what I'll do here is I'll say it's TensorFlow 1.15 GPU. It'll be a lot more proper naming. And I'm going to customize rather than, I'll check that off, and I'm going to customize rather than using the default because I don't want to use a K80. I want to use something with a little bit more power. And let's see, and I'm going to choose a different region as well, importantly. So something close to me. I'm over on the east coast of the US right now, hiding from coronavirus. Let's do East 1C, how about? And our environment, we said we wanted TensorFlow 1.15. Anything else that might look appealing here? No, it's just base images and such. And you can notice there's also the option of custom container. Don't let that first option fool you. It's not just the default placeholder. You can actually have it plug in whatever container you want. So that's also good to know. Let's double it up to 8 cores rather than 4 cores. And let's pick a, let's do the P100. Just one is good, and leave everything else defaults. So we're gonna let that create. Did I click create or did I fail to create? Click create. I did not. Gotta love those UI glitches, right? Create, please work. Product team notebooks are verified on AI platform TF 1.5. Oh, thank you. Thank you for the coverage. Confirmation there that it is 1.15. Now, why this create button won't work is very confusing and unfortunate. Let me try opening this in a new tab to see if maybe I just created like 3 in a row and not accidentally create more. Okay, so it's not going. I must have hit some kind of UI snag. That's unfortunate. Let me just try refreshing. If anybody has any thoughts on what's happening here. Because this instance is up and ready to go. It's got a P100. I might just use that for the sake of simplicity. I'll take one more stab. TF 1.15 GPU. Only digits, lowercase characters, and dash allowed. Okay, that must have been what was blocking me. I just couldn't see it because I was clicking here, and it doesn't pull me back up. So that's worth noting. Notebook create name violations don't grab attention, let's call it. All right, so lowercase characters, digits, and dash. Okay, so no dot. That's awkward. I really wish the period would be okay, but it looks like it's not. Yeah. All right. So be it. We got South Carolina. Let's continue with East 1C. 1.15, I said I wanted 8 CPUs and I wanted a P100. And I want to install those GPU drivers for me because too much work. All right, so that makes it work then. So that was a rather silly mistake not seeing the naming convention violation there. So for now, let's open this Jupyter Lab and set up our steps. In the docs that we were looking at earlier, we saw that they wanted us to download the Git repo, and we'll set our buckets. Whatever buckets we end up using, we'll probably use either the same or similar buckets to what we used last time. So you can see when I go into this notebook, the work that we did last time with creating that custom container is still there, and the state is saved, even though I haven't necessarily touched this notebook yet. So it's, even though the notebook shut down and spun back on, it's all still there, which is really quite nice. So I'm going to go ahead and close these tabs. And let's see where we are in this space. Let's go and create maybe, oh, so there's CloudML samples master, but that's not where we are. We're in AI platform samples. Maybe, oh, this is still going. It would be awfully nice to pick up this one. It's not only, this is on the West Coast, so if we can get to the East Coast one, get that spun up soon, that'd be great. For now, let's journey on forward, and we'll come back for it. Let's take a look at what buckets we have available to us. Set up our kind of workflow with multiple tabs of notebooks and storage and logging. Let's see if I can't make this a little bit bigger. All right, so we have a lot of options. I got a lot of folders to play around with here. Let's see what's in CloudML demo-us. Sure, this seems fine. I really should make a bucket for the show. Yeah, why don't we do that and save ourselves a lot of headache, because I made a custom containers bucket and there's just no need for that, honestly, in the end. Adventures with Yufeng. Great. Well, dashes are okay, I hope. And we'll leave it single region again, and this is where I want to go back and say this is going to be East 1 C. Just so that there's no confusion about where this is going to be. Oh, it's region, so there's no C. Ah, get rid of that. It's not a zone, it's a region. So zones have those letter suffixes, and everything else can be standard, and I'm going to hit continue and let that create. So this is going to be my kind of default bucket name going forward, and that's where I'll kind of open up my folder structure. And I see that this is done creating, so I'm going to move over to that. We'll close out of that one, reclone everything. So we want to set this variable, as we often do. And what's unfortunate is that every lab or sample tends to use slightly different conventions, whether it's GCS bucket, storage bucket, cloud bucket, or just bucket sometimes. They don't always use the same environment variable in all caps name. So let's open a terminal. Oh, I did want to check Python version. So the default now is Python 3.7, which is great. The old one, which I think we can pull up, I'm just going to undo that tab closure. It was, if you just ran Python, it still pointed to Python 2, which was a bit of a nuisance. You had to type out Python 3, and even then it would be 3.5. So now with 3.7, we get f strings. We get, I believe we get the class structs. I forget what it's called. Those class-like objects, the handy dandy Python improvements that have come with these most recent versions of Python. I think I still have this pasted. Yes. All right. So we'll clone that repo. Try to make this. Ooh, it might be too big. Ah, there we are. A quick repo clone, and we're in home/Jupyter, and we have our AI platform samples. Wonderful. We're on our way. We have our bucket, and we have this next step. Oh, we should go back. Yeah, this is the real one we're working from. So this variable is used in submit the Hypertune job to execute locally or using a platform, build a custom container using the build script. Okay, so here we'll build this is very similar to what we did last week, where we built our custom container. I want to take a look at this bash script while this is running, build.sh. Looks like it's in this folder, handy. So I'll open that one up. And all that's doing is it's setting the project ID, grabbing estimator-hypertune, image tag latest, and so this will pull together to be gcr.io, so that's Google Container Registry.io slash our project ID slash estimator hypertune latest. And our Docker file, let's go back and look at what that one reads as. So that's where the interesting stuff is. We took a peek at it earlier when we were trying to figure out the TensorFlow version. We're going to grab from the deep learning containers, so it'll be an environment that matches the one that we're in, which is really nice. And we'll pip install CloudML Hypertune, which we'll need. And then it sets the working directory at root, and it copies the ResNet folder over and starts running ResNet, the ResNet, what is it? Not module, I'm blanking on the word, package, and the module ResNet Main Hypertune. So now we can dig into this and see what exactly will happen when this code is executed. So this is kind of the workflow for tracing out, what's going on. We're digging in from the build script to the Docker file, from the Docker file now down to ResNet/ResNet Main Hypertune. We're getting to the source of what exactly is going on here. And before we do, let's take a peek here. We're still building. Again, this is building on our virtual machine, not on my local machine, thank goodness. And those 8 CPUs are getting a workout. Let's take a peek at that. Actually, you can click on this and you can see the compute engine instance. You can see this is actually the compute engine UI. We can go over to monitoring and maybe see the CPU spike and the network spike from what we were just doing. We might have to wait a while for this to all kind of load in, but I'll leave this open. We can let this refresh later. It'll be interesting to see. I don't think I need this build script anymore. This is pretty straightforward, not too much going on here. The Docker file actually ended up being pretty short as well. Let's go over now to our ResNet Main Hypertune. Ooh, there's a jump to. GitHub added this. Nice. It's not necessarily the most useful things, I guess. It's not. Is it in order? There's asserts as functions. I don't know that I believe that. All right. So I think what we are interested in, there's a bunch of argument definitions here at the top. Make this bigger. And then we kind of get into the meat of it. There's a learning rate schedule, which handles linear scaling rule, gradual warm-up, and learning rate decay. So there's a description here of what happens there. We can come back to this if it's useful, but it seems to be a pretty short function that just manipulates the learning rate to kind of adjust it as the training occurs. Going down to the ResNet model function, I'm going to flip through this and then we'll come back for it. It looks pretty long. There's some things going, oh, wow, okay. So that's most of the work, most likely. And then in the main, there's a CloudML trial ID. It's worth pointing out just as a historical note, even though it's Cloud AI Platform today, it used to be called CloudML or CloudML Engine. And so a lot of times in the source, you'll see things referring to CloudML or CMLE, CloudML Engine. So that's worth calling out. And for better or worse, this code uses TensorFlow estimators. I think that there's a lot to be said for this interface in terms of it being really good for batching out these jobs, and there's a lot of good documentation on it, though today it's not necessarily the most recommended way of using TensorFlow, especially as they are pushing more towards using Keras API. And so, they even added function lookup, so I can click on this. That is pretty cool. So that's the ResNet model function from above that we had just seen. And it looks like it allows you to choose bfloat16 or float32. I'm assuming this is a TPU compatible code base, which is exciting. bfloat16 is short for brain float 16. It's a 16-bit sized floating point number that has the same decimal precision. It has the same mantissa length as a floating point 32, float 32, and it's especially a format designed for the TPU v2 and v3. So it looks like it'll take that, and then we have ImageNet inputs. I wonder where it's going to pull the training data from. Flags that data directory. So that'll be interesting to see how that runs. Based on that Docker file, which closed, let me open that up again. It just runs it straight. So that tells me that we should look at what some of those default variables are. This should be done building by now. So I'm going to pause this, and we're going to go and see what the next step is, because it could potentially be time consuming. Okay, oh, that's the wrong window. This is the window. We're already here. Okay, let's go open that top level README again. Okay, so we built our image. Once our image is built, we can test it using submit ResNet Hypertune.sh with this test local. So submit ResNet Hypertune.sh must be where all of our parameters are hiding. Submit the hyperparameter to AI platform. This included script will train ResNet 50 for 1024 steps using a fake dataset. A fake dataset? What's the fake? Is it blank? What does that mean? Interesting. So let's take a look. Submit ResNet Hypertune.sh. We can see that that's going to be right here. Oh, and there's a config file too. Should definitely look for that. I bet it reads it in, so I'm going to open it in advance to see if we can find it. Ooh, comments. With TF2.x, TF estimators continue to be supported, but otherwise phased out as recommendation. Exactly. So you're exactly right. Especially in TF2, estimators are still there. You can still get to them, but they're not so much the recommended path any longer. So it'll be interesting to see if we can find maybe this episode, maybe a future time. I'll try to see if I can find a Keras implementation of ResNet or other kind of state-of-the-art image model that we could kind of port to this effort, because yeah, it'd be cool to see that work go. Let's see, we got our image IDs. GCS bucket is expected, so there's a kind of default value there, but you really have to provide it as a environment variable, which luckily we've done. Let me add export here so that it really gets there. Job name, ResNet. Now, like, save yourself the trouble of typing all of that, I suppose. Oh, it's already. Oh, now it's. I was going to say, I didn't realize Bash could support just a simple now. I assume that's going to show up a couple of times. Bucket/job name. Okay. I wonder what format it wants this bucket in. Like, should it be GS? Because this looks like it wants GS, but the sample specifically said to. Oh, it did have that. That's my bad. All right. I've been caught. I'm glad I caught this, though, because that would have been an awkward and kind of potentially tricky bug to sort out. Now we have a staging bucket, which is my bucket, apparently. A region has been selected for me as US Central 1. That won't do. Definitely going to have to change that. We have a fake ImageNet. I am really curious what this is. Okay, that's exciting. A fake ImageNet. All right, so let's do an ls on that. No such file or directory. Oh, right. gsutil ls. So gsutil is the Google storage utility. Here's all our images, and it just listed all of them for some reason. Don't really need all of them, just some of them. Should have done head. It's my own fault. So there's 1024 images. Oh, no, these are... I bet these are TF records. Let's take a look. I don't know how deep it'll let me drill into it here. Okay, so it's a 67 megabyte file. Doesn't have a file extension. Usually TF records are .tfrec, TFREC. So I'll be interested in seeing what that plays out as. I want to refresh this page. I see the CPU has maybe just that little spike was all that happened while we were building the image. That'd be interesting. A little bit surprised. Okay, there's the other bump. One for the download and one for the image build perhaps. And then we have network and yeah. Okay, got to stay on track here. We got data, we got output path is also the job directory, so a lot of things go into the same place. I might redirect some stuff, especially I want it to be one more directory lower, so I might actually create a subpath here and write hyper tune, 0406 for today, April 6th, and let that be the value of our bucket, quote unquote. Hopefully that will still work with all the appending of slashes and such that it's doing automatically. I think it will still be okay. All right, if test local, we just run this image locally, ResNet depth 50, and that should also show up here, ResNet depth 50, yeah. And I guess that means if we wanted a smaller network, ResNet is nice in that the architecture is very kind of repeatable, and so if you want 50 of them, you can get 50 of them, but if you only want 20 of them, you can do that as well. So I might just do that just to simplify things. So let's start editing this. This is submit resnet hypertune.sh. I think we're already CD'd into the right directory. And so let's see what we have here. Here's our submit file, right? So let's see what we got. We have our bucket name, which we could pass in manually now, honestly. We don't have to set it like this. And we have our date, which is fine, I guess. Leave that be. No need to fiddle with that. Our region is important. We want to adjust that. Did I never write that down? That was not smart of me. Let's go back. I believe it's East 1C. Yeah, you can actually see it here in the URL, which is kind of funny. But you can also, of course, see it in the details of the machine right here, zone US East 1C. So we're going to put that here. Vim. All right. Let's do. Let's change our ResNet depth, just for fun, because I just love making things more difficult for myself, right? Let's see how many we got. We just got these two. Let's just do 20 or 30. Let's stay low. Let's play it safe. Let's do 20. And we'll train it for its 1024 steps because the data is like set up that way. And it wants to do a V100. That's fine. No complaints there. And we have this config file, which we thought we would need. Got lucky on that one. We were right. So let's see what this config file has. Okay, so this is the AI platform training config. We kind of saw some of it last time on Friday. There's a custom scale tier, and we want to maximize top 5 accuracy. So that's standard kind of ResNet data set setup, and the base learning rate. Okay, that's where it's going to pick the learning rate from. It's going to pull that from that the training file. And we have a couple of parameters to kind of set that up. What's interesting is that this hyperparameter searching is really just searching for kind of learning rates and weight decays. Ooh, a question. The shallower ResNets are for small images. Deeper ResNets are for large images. Ah, well said. So ImageNet is fairly full resolution. So this suggests to us that we should keep using the big ones. Okay, but will this run forever? There's no indication of it here. Okay, let's just start it with the big one then, and see what we get, right? That's a fair point. And what's a little bit concerning to me is that the test local version, it is basically the same as the training job, right? It's like a dry run, but it is still just as big of a network. It's still 1024 training steps. I feel like for a test run, I would want to run it for, let's say, 100 steps rather than 1,000 steps, because the whole point is I want to train it for real later. And so I'm okay with it not having a good result early on. Hopefully, if I read this correctly, in which one? In the docs that it came from, right? It talks about this time how to run a hyperparameter tuning. Oh, well, I was hoping it was a fine-tuning job, not like a train from scratch job, but we'll see. Let's run this total. And so this is also an interesting note here is this workflow, right? You can see that what they've done with this repository is created a number of bash scripts that capture the intent of the authors so that you can directly use these bash scripts to do them. You can version control it. It's a lot less ad hoc than perhaps writing instructions into a README to say, run this command, now run this command, now run this command. So it's a little bit more of a packaged job. Let me make a note here in the live stream chat and say, good thinking. We'll stick with 50 depth for now. And one of the things that might be worth trying to figure out, I don't know that there's a good way to do it from the information that we have, is what does this fake data set look like, right? It said it uses this fake ImageNet, right? So firstly, it's worth knowing what does ImageNet image resolution come out to be, right? So it is at least 256 by 256 oftentimes, and you can see it here, average is 400 by 400, so it's on the larger side of things. And so unless we downsample it, but the real problem is we don't have the code for how this data got here. You saw in earlier when we were looking at these files don't have an extension. So we don't know how they were formatted to get here, and there's no documentation that I can see that explains it to us. What we can do is look at the actual model code, which is where I am, the ResNet Main, and see where it unpacks the data, right? And that would give us an indicator of what it thinks it's, what it would like to receive at the very least. Let's do that then. So we have that task, and I copied something. Where did I paste? Oh yes, I wanted to see if I could browse to it perhaps in the bucket. I wonder, there won't be anything here because I just did a local run. But if I take this and I remove all of that and I paste in this, fingers crossed, fake ImageNet. Don't know if this will, all right, so this gives it to us. So these files are all the same size. They're exactly what we thought they are, right? For better or worse, they're multi-regional, so they're not ideal for kind of high performance training. You'd want it to be a single region, and specifically the region that your compute lives on. I'm a little bit concerned that this training is on step 1 and we have a hyperparameter tuning job that we want to run with 1,000 steps each. So it's very possible, for better or worse, that we won't get to necessarily see the results of this until perhaps hours, maybe even days later. ResNet default is 224. Okay, that's where that number comes from. I'd always wondered about that. So, well, I'm glad we stuck with 50 layers then, I suppose. All right, so it looks like our script works. And so I'm inclined to copy this over. Maybe we should wait till we at least get one more step 2. Well, it might not checkpoint every step though. So let's take a look at the source code while we wait. Where was that? Okay, so here's the source code. We'll go up to ResNet model function, features, labels, mode, params. Just search around for this then. All right, let's see what features what it's gonna do. It's a tensor of batched images. It's expecting it to be already processed. Okay, so that tells us something about who's calling this. This is the definition. References. 0 references. Good stuff. All right. Clearly there's a reference and it's here. So model function, params, batch size, estimator, ResNet classifier. Okay, so that's just creating the function. So where do we call the train? It looks like it's here. Image pipeline is slightly different between training and evaluation. So if eval, the eval steps is this, and we check evaluation per checkpoint. So that entire for loop is there. Else, it's train or train and eval. Get the current steps, batches per epoch. If mode train, training for trial, blah, format. So are we seeing those print statements, or are they too buried? Calling model function, graph finalized, XLA initiated, saving checkpoints, loss. So not the most informative print statements I've ever seen in my life, but all right, let's see. We have training trial, checkpoint, flags mode. There's a Hypertune hook. So this is coming from that Hypertune library. So now that also is an interesting hint around kind of exploring the hyperparameter tuning bits of this. The ImageNet.train.input function. So that is the function that controls the data input. So this should give us a hint as to the ingestion. So that's coming out of here. ImageNet.input.ImageNet_input. Training data directory, transpose, use bfloat for is training in true-false. That's funny. So it's like, it's doing both, right? It's doing the training and the eval one. That's a clever trick. Might be a little bit obfuscated for my taste, but it's saying basically one is for training is true, one is for training is false. So it's storing it in ImageNet train and ImageNet eval. So instead of having to call this function twice, that's a clever thing, but it's debatable whether or not it's quote unquote Pythonic, but it's clever. Definitely give you that. So let's find this ImageNet input library, right? So it knows how to grab stuff clearly. It even has an image serving function from .import ImageNet input. Was this in the same folder all along? Surely somebody could have clued me in on that. Let's see here. This is the submit. I want to keep the submit up. I can drop this YAML from now. Let's see. ImageNet input. Okay, so there's our answer. It is local and custom. Serving input function is there. This ImageNet input generates ImageNet input for training evaluation. We're assuming TF record with keys as specified in the dataset parser below, sharded across 1024, named sequentially. Okay, so this is the answer to all of our questions. Validation in 128. So this is a very hard-coded file. It's expecting a very specific input. So if you're going to reuse this, you've got to come in here and update some of these assumptions. That's important. And you can see here that the dataset parser is expecting all of these encoded attributes. Everything from bounding boxes to the class label, class text, and class label again. Oh, for the object. So this is the class label for the image. This is the class label for the object that's in the box. So that's good to know. Good to know. And it's got the parse single example. It's going to reshape it. It's going to call its own image preprocessing function, which I assume is somewhere in here. The input function, what is it doing here? It's grabbing the files. It's fetching the, so it's defining this little fetch dataset helper function, defining 8 megabits, megabytes, the MI per file. It's not megabits, but it's the power of 10 versus power of 2 thing around So it's approximately 8 megabytes computed this way, base 2, and we create our TF record dataset. Great. And it points it to the file name, and it grabs, the buffer size worth of TF records. Then it does a dataset apply where it does a parallel interleave with cycles and shuffles. Fair enough. And okay, so I wonder if there's a file in here. I'm just thinking ahead for folks who might want to reuse this for generating the TF records that it's expecting to have access to, right? In terms of something that will shard into 1024 for the training and 128 for the validation sets. ImageNet input, we have that. Hypertuning hook, ResNet model. I know it's not like part of the point of this repo, but that would be an interesting idea. This is seriously stuck. I think what I'm going to do is push this to the background with Control Z, BG, and then kick off the cloud job, submit. Before I do that though, I need to set the exported GCS bucket variable, otherwise I'm going to have a bad time. It is saving checkpoints. Look at that. It's doing some stuff. That's exciting. Doing things. Okay. Fire it off. Do the thing. Ooh. I did not like it. Ooh. US East 1C is not available. Oh, region, not zone. Where did I do that? Why are those two still running? All right. Okay, so this is the Vim job that I was looking for. I can't believe I made this mistake twice. That's embarrassing. Okay, write that off. Rerun this. Should have just left it on US Central 1C when I had the chance. Oh, and we're back. That's crazy. My internet went out for a bit. The notebook dropped connection, and let's see, is this, yeah, we're back up again. Wow, that was crazy. And I lost the connection to the notebook too, so it like completely shut me out. So what got submitted? I wonder if it was, the timing is kind of crazy, right? I submitted a training job and then everything went away. Like my network just went to 0, but the training job never went. So try it again, I guess, right? Like this is my fool's errand here. If at first my training job does not run and instead cuts off my network, just run it again. What could go wrong? All right, so if my internet goes out again, we'll know it's because of this bash script in a VM not connected to my computer or my network at all. Or perhaps what it's doing involves uploading a huge file. No, it's all in the cloud. So I'm not worried about that. Sometimes freak lightning storms happen in the middle of nowhere and your internet disappears. All right, so we had the Docker file, we had the original source repo, the Python file, the folder, the script. Okay, so the script is just calling AI platform job submit. So that should work, except it does not like me because US East 1 does not have accelerators of that type. That's a fair enough point. Again, this is what I get for trying to mess things up. So let me fix that, and then we'll talk a little bit about what you can do to A, avoid what I did, and B, figure out what regions are available, because not everybody wants to run their training jobs in US Central 1. So I'll make a note of that so we can talk about it. And meanwhile, we need to fix this problem. Yeah, So that's what I thought. This container doesn't exist. Oh, it should be the container I built. Why is that step missing? Like, we built this custom container, and then shouldn't we be using that container? What container did I build? Build.sh. Let's take a look. Then build.sh. So project ID, image repo name, image tag. So let's echo that value, shall we? Image URI, because we want to make sure that that's there. And I want to not run it again, but because we've already run it. So I'm going to save. Ugh, that was not great. I just saved a file called backslash. All right, let's try not to blow things up. Is this how you remove a file named backslash? Yes, it is. And so I'm going to rerun the build.sh, which I've already made a dry run. Okay, so there's our real library name, gcr.io value. Now I'm going to go back and undo that because, okay, quit out of that. Now let's make sure this exists. Well, firstly, what are we using, right? We're gonna look at the submit script. It's using project ID, image repo name, image tag. Why wouldn't this work then? It's using the same exact thing, so it's doing the right things. Let's see why. Let me paste this down here so I don't forget it. It's so useful to have a text editor just always sitting there at your disposal to like drop random words into. So that is the same GCRM. Did I not push the image? I thought I built it. Failed to read the container URI. Please make sure and the CloudML engine service has access to it. So let's go into container registry, because I have a feeling, an inkling, directionally what might be going on here. Perhaps container registry needs to be aware of the existence of, let's see, as it says, again, CloudML engine service. Bad naming. I'm going to take a screenshot of that so I don't forget. And we're going to go over, we have our three things. Why is it that we only have our three things? That part itself is suspicious. So that says that we didn't properly build that image. Okay. I could have sworn we did, but we'll run it. Do the thing. Yeah, do you all remember? Yeah, I ran that train, right? It even grabbed it. It knows it's there. It successfully built. It tagged CloudML demo / estimator - hypertune. So where is it? I mean, this is just nuts now. I'm baffled. The build script that we ran, Docker build, like that's just like a normal, isn't that not a normal Docker file thing? I even have our notes from last time open here. Docker, oh, this is compute engine stuff. Dockerize, this is for creating Kubernetes clusters. Not exactly what I was looking for. Then Docker file, export a project, Docker build, yeah, -t. Oh, there's, yeah. We built the image, but we did not push it. We did not push it to the container registry. You build it, and then you gotta push it. And if you don't push it, you're stuck. You're dead in the water. All right. So now we know instructions are incomplete. All good. We can work with it. Project ID. What did we? I'm just gonna copy this in because this is for simplicity's sake. So we're going to run the auth command. We're going to push the image. My config file has these credential helpers. Yes, please. Pushing. Now it will go and happen really fast, suspiciously fast, but I hope that's okay. All right, fingers crossed. Refresh. Yes. All right, so our image finally exists. Now let's hurry up and at least kick off this submit ResNet Hypertune job. For crying out loud. We got to really pick smaller models in the future. I think that's the lesson, so we can actually train them in the hour, right? Like training image data sets is great. You have to have the right kind of tools, the tuning, of course, the compute horsepower to get it done, but also just there's so many bits and pieces to connect. So this is kind of the fix I've got for you, for those who are, following along at home. After you run build, I don't think it said you had to push it, right? You run build and then you try to run submit, and it just does not like you. So you gotta have build and then you gotta have submit. It looks like you can just do image URI :latest. So in that script, it would be something like URI :latest. You might have to also pre-run this. It seems to run without issue. It might already be pre-authenticated. I'm not sure, to be honest, but yeah, might even just submit a PR just to add those 2 lines to this build script. So there you have it. I'm going to refresh this. We got our hypertuning job running. Custom code training. Hypertune is yes. Hypertune parameters are listed there. We got our metric. We got our create time. It's going to take some time to create. So for now, I'm gonna call this a day, and maybe just to recap kind of what we did today and talk a little bit about what we have planned. So today we tried to run some hyperparameter tuning jobs for ResNet to tune the base learning rate, momentum, and weight decay. Now, where we kind of fell short was in a couple of aspects around getting the image built, had some regional issues of selecting the wrong region. Either the compute wasn't available for the V100s, which is what this training job is using, or I typed in a zone when I should have typed the region. We had a Docker image that built but was never pushed to the container registry. So a little subtlety there. So glad we went through the container stuff on Friday. So otherwise we would have been totally at a loss for what to do, because this is one of the dangers of blindly following instructions, is when something doesn't quite work, you lack sometimes the wherewithal to know where to go with that, right? You kind of end up just bumbling around. You have one narrowly lit path, and if you stray from that path ever so slightly, you're in the darkness. And so the hope is that, with these live streams and these videos, that we can A, make the materials better, but B, have a way to fill in those gaps, so that if you do kind of wander off, as I sometimes will, as I perhaps overzealously will adjust the instructions and try to do something that's just a little bit different than what the original authors intended, which I think is a realistic simulation, right, of what oftentimes when we're taking a tutorial, we're like, we want to use it for our use case. Like, you wrote a nice tutorial, but I want to change it. And so yeah, the hope is that these are helpful, and feel free to let me know in the comments here on the live stream, or if you're watching this later, down below in the comments under the video. For as far as schedule wise, looking ahead, this week, I'll plan on being here live with you at 3 p.m. on Wednesday, and then again on Friday. There's a couple of content ideas I have in mind. If you have any requests, please let me know. I'm on Twitter at YufengG, or you can just drop a comment under the video. I'll be trying to keep an eye on that. So with that said, I'll try to update you all on how this tuning job goes. Last time on Friday we did this tuning job, and I think the best outcome was down here, 0.049. Our naive training got 0.09 for the loss, so it was quite an improvement, almost half as low of the loss, which is lower is better. And so that was trial 16 out of 20, and I was pretty happy with that. We were running, I think it was 5 trials in parallel at a time, and so it did 4 batches of 5, and each one was about 7.5 minutes. So over the course of, what is that, 4 times 7, call it 30 minutes or so, we were able to run 20 training jobs and come up with a nice, finely tuned set of parameters for learning rate and momentum. So that was really neat. And so this, in some ways, is an exercise in a similar sense, just at a bigger scale, right? ResNet is a much larger model. ImageNet is a much larger data set. And so I suspect that ResNet 50, especially given the number of trials that it wants to run, given the number of training steps that each one is going to do. Oh, we got the arrow. So it's running these 2 in parallel. We see our values here. Glad we stayed on. We got to catch a glimmer of the training job getting underway. We can see that they're quite different. They're different base learning rates, different momentum, and a very different weight decay. This is going to be really interesting. Oh, there's a -5. I was going to say this is 6.3. It's unheard of. Like, what does that even mean? This is what? 0.2, 1, 2, 3, 4. So to the -4. So this is 10 times smaller, this weight decay, than this one. This is 2.5 times 10 to the -4. So we'll see how it goes. And if you want to catch the results, I'll try to post the final outcomes up on Twitter on the tweet that I used to kind of announce today's live stream. So with that, hope you enjoyed it. I hope this was at least, if not overly educational, at least somewhat entertaining. And I hope to catch you next time this week, Wednesday, 3 p.m. Eastern, noon Pacific.